So at this point, we're ready to prove the first of the statements about uniform convergence, namely that if you have uniform convergence of functions and if each of the values f sub n is continuous, then the limit is continuous on the set G. So remember the setup is that we have a sequence of functions f sub n, which maps some set G to the complex plane. And we're going to assume that all the values f sub n are continuous and that we have uniform convergence. What I want to do before I actually go through and do the proof is explain the idea. And the idea is that we want to bound f of z minus f of z naught if z minus z naught, so if z minus z naught is less than some delta. Okay, that's what we want to show, or that's what we want to show, it's what we want to do. And notice that f of z minus f of z naught is going to be, well, before I get into that, it's going to be equal to, what I'm going to do is I'm going to add and subtract in a few terms that'll help us. So f of z minus f sub n of z, we're going to use convergence, so that's going to be small. And then I'm going to add that back, f sub n of z minus f sub n of z naught. That's going to be small because we're assuming each of these f sub n's is continuous. And f sub n of z naught, f sub n of z naught minus f of z naught. That'll again be small because, so this will be small, this will be small, and this will be small in modulus. So if we apply the triangle inequality, we'll get that this is less than the modulus of the first two terms plus the next two terms. Okay, and then finally the last two terms. And so the first and last terms follow from the fact that f sub n converges uniformly to f. So the values that we're going to get for capital N are going to be independent of z, and therefore they apply equally to the first and the third statement. And then for the middle statement, we're going to show that this is going to be small if z minus z naught is small, because we're assuming by definition that all of these f sub n's are continuous. Okay, so this is the idea. Okay, so this is the idea. So here's now really, I shouldn't have called that a proof, that was kind of a sketch. But here's now where the proof starts. So let's let epsilon be given. Okay, and I want you to notice that since f sub n converges to f uniformly, I'm being slightly redundant here, but since f sub n converges to f uniformly, that means that there exists a capital N so that so there exists a capital N so that if little n is greater than or equal to capital N, then f sub n of z minus f sub minus f of z is less than epsilon, just so long as little n is greater than or equal to big N. Okay, and that's true. I've already written that, so I don't need to write it again. But this is true for all z. Okay, so this is true uniformly for all z in G. And then likewise, so very similarly anyways, since each function f sub n is continuous, so since each function f sub n is continuous on G, then there exists a delta so that f sub n of z minus f sub n of z naught is going to be less than epsilon whenever, z minus z naught is less than delta. That's what I want to say. Okay, that's the normal definition of continuity. Notice that this is true for each n. So what's actually going to happen is that for n equals 1, you'll get a delta 1. For n equals 2, you get a delta 2. And then let delta be the minimum of all those, delta 1, delta 2, and so on. Okay, and so that's going to be, that'll be the story there. And then if we put everything together, so putting it all together, what's going to happen is we're going to get that f of z minus f of z naught is going to be, we said it's less than or equal to f of z minus f sub n of z. okay, plus f sub n of z minus f sub n of z naught plus f sub n of z naught minus f of z naught. So again, playing the triangle inequality 3 times, adding in 0 twice, just being creative about this. And this is going to be less than epsilon over 3. This is going to be less than epsilon over 3. And this is going to be less than epsilon over 3. And the reason I can actually go back and change, I should have actually changed this to epsilon over 3s. And the only reason to do that ahead of time is so that when you put it all together, everything adds up to epsilon, okay? And that this holds when little n is sufficiently large and importantly, z minus z naught is less than delta, okay? And so in particular, if z minus z naught is less than delta, then f of z minus f of z naught is less than epsilon, okay? And since you have little n's here, you need that stuff happens when little n is sufficiently large as well, okay? But altogether, this is what we get, okay? So it turns out that if you have uniform convergence of continuous functions, that's also continuous.